limit of n going to infinity of the width, right? The width stays the same. What is the width going to be? 2 over n times the summation of I equals 1 to infinity, correct? Well, I always do that. I'm sorry. It always goes to 1 n. I did that yesterday too. 1 to n, correct? Well, it's going to infinity. It's not quite the same. Of what? The function. So it's going to be 2 minus, right? And then what's this going to be? 2i over n, all of this squared, right? That's right, the sum of them. Yeah, very good. Nice. Okay, so now you need to actually, this is that first step, which was write the limit expression. We had 4 steps yesterday that I ended up the notes. So now we need to simplify. So one thing we can do, we have the limit as n goes to infinity of 2 over n times, we can break that into two sums, right? I equals 1 to n of 2 minus the summation of I equals 1 to n of 2i over n squared, right? Can someone tell me, just tell me, what does this mean right here? What does that mean? 2 plus 2 plus 2 plus 2, how many of them? So what does that equal? 2n, exactly. So let's just do this out. Piece by piece. Limit as n goes to infinity of 2 over n times 2n minus, and what can we factor out of here? 4 over n squared, correct. Minus 4 over n squared. Why can we factor that out? You can. Well, why can you? Because in terms of just this, I squared. Thank you. That's important. Yes, I squared. Yep. And just looking at that, n is constant. Just looking at that, it changes later, but we don't care if it changes later. We're here about right now. Okay. What does this mean? Can someone tell me what this means right here? Up to n squared. So that's the sum of the first n squareds. N squares. So you have the limit as n goes to infinity, 2 over n times 2n minus 4 over n squared times, do you remember what it is? N plus 1 times 2n plus 1 all over. It would behoove you, because I've told you already, you must memorize that. Yes. And at this point, what was that one thing I told you should kind of keep track of as you're doing this to make sure? You want to simplify, but what should you be paying attention to? The powers.
If they're not.
Good answer, Mr. Powers. Awesome. What do we hope what about the powers, Mr. Power? We want them the same on the top and the bottom, because if they're not,
You're screwed.
You're screwed, because it's either you're trying to find a definite integral, something that has an answer, a numeric answer. If the powers are not equal, it's either going to 0 or infinity, and you don't want that. Those are not definite. So at this point, what is it just a matter of? Yeah, yeah. Now it's just algebra. Ready? Ninja. Okay, now it's just algebra. The limit as n goes to infinity of 2 over n times 2n minus 4 times n squared plus n times 2n plus 1 all over what? 6n squared?
What?
6n, thank you, 6n. 6n, thank you. 6n squared. 4n, 4n! I multiplied it in! Don't get angry at me!
Why you put that in?
Why not?
You can just
What'd I do wrong? What? What'd I do wrong? I just did this!
No, it has to be. Why don't just divide n for once?
You just take it out.
Well, yeah. It's taking it more difficult.
No, okay. Okay, so you want me to cancel first? Okay. You really didn't like that? That's fine. That's fine. Don't hurt me. 4n plus... Oh, well, you want to cancel the 4 and 6, don't you, too? Okay, so that becomes a 2, and that becomes a what? Can I multiply it now, please? 2n plus 2 times 2n plus 1 all over what? 3 what? 3n. Okay. Yes, that's all recorded. 2n minus, what do we get? 4n squared plus
In the hotel room.
plus 2n plus, so 6n plus 2 all over what? Yes. Thank you, Tony, backing me up there. Good job. Okay, so we end up with limit of n going to infinity, 2 over n 2n, well actually no, it's going to be 6n squared minus 4n squared minus 6n minus 2 all over.
Minus 2?
Yeah, minus 2.
All minus.
It's all minus.
Oh, right.
What? Tell me what's wrong. I'm subtracting the whole thing, right? Okay, so let's multiply it all out now, right? So what do we get here? 2 times 2 times 2 is 4n squared, right? Because you get 6n squared minus 4n squared times 2, so what? 4n squared minus 12n minus 4 all over what? 3n squared, and what's that limit going to go to? 4/3. All done. One left. I just multiplied the 1/2 in and then brought that down. So this cancels with that, right? Correct. So what are you left with? You're left with 1/2 b squared minus 1/2 a squared, which is b squared minus a squared over 2. So did we just geometrically prove this? Yes. We're going to prove this using calculus. Okay, so we're integrating
What
from
happened to the other a squared? Was it then?
the other a squared. That a squared went. Which a squared?
He combined them.
Look, 1/2 and 1/2, right? So there's the first 3 terms right there.
Yep.
I multiplied it by 1/2, and then the other a squared is right there. 1/2 a squared minus a squared is negative 1/2 a squared. Okay, so now we're doing this. We're doing the integral from a to b of x dx. So you're using calculus to do this. This is going to equal the limit as n goes to infinity of what? Not 1. What's the interval this time? B minus a over n, right? Times the summation of I equals 1 to n, right? And the function is really kind of easy or nice, right? What's the starting value? You have to be very careful about this. The starting value is what? A plus b minus a over times I, right? It's starting at a, right? You're starting at a, so you need to clean this up. But what are b and a? B and a you treat as what? Constants. They are not variables. Are they changing at all throughout any of this? As I changes, are they moving? As n changes, are they moving? No, they are not. They're constants. They're 6 and 3 in your head. You don't combine them. Okay? So if you do this out, if the limit as n goes to infinity of b minus a over n times this thing right here. So what did we do? We tended to break these things up, correct? So we did the summation of I equals 1 to n of a plus, and what can we factor out of the next one? Oh, we can factor that out, can't we? Yeah, why not? Because b and a are constants, is n changing as I changes? No, n is changing as n changes, not as I changes. So on this one, can someone tell me what this is? What is that? A plus a plus a plus a plus a. How many of them? So you have the limit as n goes to infinity of b minus a over n, right? Times what? I keep things in alphabetical order. It's okay. Plus b minus a over n. What's this? What is that?
N times n.
Nope. What's the first term? It's 1 plus the sum of the first n integers. What is the sum of the first n integers?
Plus 1 times n plus 1.
Over what? 2. It's the sum of the first n integers. Absolutely. So now when you clean this up, do some things cancel now? Yeah, some things do cancel. You get b minus a over n times an plus, that cancels, right? So what do you have? B minus a times n plus 1 all over what? 2. What should I do at this point, algebraically? Multiply out the top right there? We can do that, sure. So you get limit as n goes to infinity of b minus a over n times, we want a common denominator, so I'll do that as well. 2an plus, what do you get here? bn plus b minus an minus a all over what? 2. Do a few things cancel there or simplify a little bit? Did I do something wrong? Yeah, go ahead. The an's, thank you. So you end up with the limit as n goes to infinity, b minus a over n times, how many an's do we get? One of them, right? Plus bn plus what? Plus b minus a all over what? 2. Great. Nice. Multiply it out. We just need to be pretty careful, right? So it's the limit as n goes to infinity of multiply everything by b first. Is that okay? So abn plus b squared n plus b squared minus what? ab minus a squared n minus abn minus ab plus a squared all over what? 2n. That's, you better have that, right? Now do anything cancel in here? I think there's ABNs cancel, right? Those go away. And then what?
No.
Then what are you gonna be left with?
There's two negative.
Yeah, there's gonna be some combining, right? And it's what do you think the most common type of error is on this type of question? Yeah, so we took care of the b squared n's, right? There's one b squared in there, and there's two negative ab's. Thank you. Minus what? 2ab, and then what? Minus a squared n all over what? 2n. So we're looking as n goes to infinity. So where are our n's here? We have an n. I'm just going to circle the things with n's here. We have this, and we have this. Correct? So as n gets really, really big, what are the only terms that matter? Those three. Those three terms are the only ones that matter. What happens to the relative importance of these middle things right here?
They just kind of throw off.
They get really, really small in comparison to the other ones. They get really, really small in comparison to the others. So the way you can think about this, just logistically, limit as n goes to infinity of, on top here, we have n times b squared minus a squared plus b squared plus a squared minus 2ab, like this, all over n times 2. I just rearranged it. I haven't done anything other than rearrange that right there. Keep in mind, b and a are just what? They're just constants. So this limit is going to be equal to that right there. So what is it going to be equal to? N times b squared minus a squared all over n times 2, which is what? B squared minus a squared all over 2. Because as n gets huge, the relative importance of b squared and a squared and 2ab, they become insignificant. They're negligible. That's right. Correct. Be interested in anything with n in it. So actually, let's actually hold on. No, it's actually, we want this one right here, right? There's this one,
The next one, you missed the. Yeah. It's like all of them.
We're looking at this. Okay, that's great.
But if you eliminate the others without adding in that other first term, will that?
We have to be careful. No, exactly. We're not eliminating them. We're paying special attention to them at this moment. So just to make this even more fun, let's just keep on going here. The limit as n goes to infinity of, I'll make it really tiny, skinny, right? We must say over n, right? Are we right? Times what we have to multiply by 6n over 6n in order to get this common denominator, right? Let's see if I can fit it all in. You ready? So it's going to be 6abn squared plus 6abn minus 6a squared n.
No, you cannot.
Plus 2b squared n squared plus 3b squared n. And we're going to pause here